We're going to find dimensions. We're going to find x and w. That minimize the cost. Key term minimize of the cost. Objective function is the cost function. Okay, so the cost gonna be the cost of the boundary. Okay, the boundary plus the cost of the dividing fence. Okay, because they are not the same. They don't cost the same. The surrounding costs like $5 per meter. Now from these dimensions, what do we know? We know that we have the material like 54 square. I'm not the material, the area, because the unit is square meter. So the area is 54 square meters, or the limitation. The area, which is the length times the width, the length times the width, the length is the x and the width is the w. Area 54 equals x times w. Or we can say the w is 54 divided by x. The restriction, yes, x cannot be 0, so x has to be greater than 0. That's one of the constraints that we can put together as the limitation or the interval of interest. So for the cost, the boundary cost, that means the surrounding, you have the length as a x, the other length is another x, and the width is w. The surrounding would be 2x plus 2w, 2x plus 2w, right? The x plus w plus x plus w. And the cost of the parameter is $5 per meter. So multiply by 5. And added by the dividing fence, because this is right in the middle and has the same dimension as the width. So the length would be, the measurement would be W, and the cost of dividing fence $2 per meters. And I use the notation C as a cost. Okay, this is the setup. And we're gonna simplify because right now we have cost depends on X and W. We're going to consolidate and then use the constraint to make or to eliminate one of them. And then the cost will be just a function of one variable. Simplify. So this is going to be 10 times x plus 10 times w plus 2 times w, or 10x plus 12w as a cost. We found the w in terms of the x, so we're gonna replace w here with the 54 divided by x. Then the cost is 10x plus 12 times 54 divided by x. And 12 times 54 is 648. So c equals 10x plus 648 divided by x as the objective function. Okay, x greater than 0, and yeah, x has no end, no right end, so it can be as greater as you can go. But the main part of this is to minimize the cost. We're gonna find the two numbers, the x and w, that give the lowest value of the cost. So for this one, let's c equals 10x plus 648 over x. Find the critical number as c prime. We get as 10, and this is similar to the last situation as 648 multiplied by x to the negative first. So the derivative is negative 648 divided by x squared. Write it in one fraction. So 10x minus 648 all divided by x squared. This is x squared, sorry. And then two cases, the c prime. equals 0 and C prime undefined. I'm going to write undefined on the right side here. So C prime X undefined for two cases. For case 1, the C prime equals 0. So 10x squared minus 648 equals 0, or x squared equals 648 divided by 10, and then take the square root of 648 divided by 10, which is 64.8. And next, we just, for the undefined x squared equals 0, which not applicable because we want anything that greater than 0. Then put in the calculator for 64.8, take the square root. Now we get 8.05, or about 8.05. If x is 8.05, so the width, which is 54 divided by x, 54 divided by 8.05, then we get about 6.71. And now we get the dimensions that give the minimum cost based on this condition.